Okay, so today we're going to look at, or we're going to add, the next way that we can add systems. Okay, this way is going to be our sort of workaround for when our graph doesn't fit what we want it to fit. Okay, and today we're going to talk about solving systems with substitution. And here's the deal with substitution. I would say that substitution becomes my students' least favorite way to solve because substitution is an option that's always allowed. It does always work. But if we choose to use substitution all the time, it can get really messy. So we're not going to look at how can we solve every system by substitution. Instead, we're going to look at how can we solve systems that are easy to solve with substitution. Because there is still a third way that we're going to look at solving as well. Okay, so since I already know that substitution is something that as we get into the more challenging problems, my students are like, I hate this. We're only going to look at solving with substitution when it's convenient to start with. Okay, for substitution to be convenient, we have to have one equation. Now, it could be two, but we need at least one equation to say x equals or y equals. If we don't see that, we don't want to solve with substitution. Now, I always tell my students to make sure when I'm saying x equals and y equals that we're agreeing here. Right? This says x equals, so this would be a fair game for substitution. Okay, you can't look here and say, oh, but Mrs. McKinney, that says y equals in the middle of it. Right? For it to be x equals or y equals, we need x or y by itself on one side of the equal sign. Lily, that needs to go. Okay, so x or y equals means that it's by itself on one side of the equal sign. If we know that's the case, then substitution is usually pretty user-friendly. Okay, now, I am not going to look at problems that are forcing us to use substitution because the numbers are too big to graph. So we're just going to pretend today that graphing isn't an option no matter what. So we can stick to smaller user-friendly numbers. Okay, so let's say we are given y equals x minus 3. And y equals negative 3x plus 25. This would still need a pretty big graph. Okay, but it's not completely ridiculous. Okay, so y equals x minus 3, and y equals negative 3x plus 25. So if we look at this, we should be able to say that this is one that would be reasonable to solve by substitution because we have at least one equation that says y equals. What does the word substitute mean? And it doesn't even have to be math related. What does substitute mean? What?
Like in place of?
Something goes in place of something else. Okay, so let's say you're cooking something and the recipe calls for butter, but you prefer to use margarine. My students always look at me weird. I think you guys call everything butter.
Because it is.
But everything is not butter. Okay, so like margarine is like the majority of what you see at the grocery store.
Which is butter.
You know, like Blue Bonnet or I can't believe it's not butter or all those things. Those aren't really
Wait,
butter.
That's actually not butter?
That's actually not butter.
Yes, it is.
It is margarine.
It is butter.
Okay, you can't put in butter and margarine into your recipe, right? You choose to put one in place of the other. Something goes in, something comes out. Okay, same idea is going to happen here. We want to substitute. That's why it's called substitution. So to make that substitution, our step one is going to be to circle where we see x equals or y equals. Now, if you come up to me and you say, Mrs. McKinney, do I absolutely have to circle an x equals or y equals? Is that going to make me get the problem wrong? No. You don't have to circle it, but if you come up to me and you say, Mrs. McKinney, I don't know how to do this problem, and you haven't circled the x equals or the y equals, I'm going to say, do step one. Okay, because it's visually going to help you make that substitution easier. Okay, so if we look over here at these problems, where do we see x equals or y equals? Sure, at the beginning. We see it at the beginning of both of them. We just need to pick one. So right here, I see y equals, so I'm going to circle that. And that's literally all it requires for step one. Step two. I am then going to underline what it equals. Again, not truly a requirement, but if you don't do it, I'm not going to help you. So we're going to look and say, okay, here's the part that I circled. Now I'm looking at the other side of the equal sign and I'm underlining what it equals. So far we've done like kindergarten work, right? A circle and an underline, we can do that. Step three. Ooh, not too close. We are going to cross out the letter we circled in the other equation. Okay, we are going to cross out the letter that we circled in the other equation, not the one that we've been working on, but in the other one. So if I look at this top equation, what letter did I circle?
Y.
Y. So I'm going to go to the other equation, and I'm going to cross out that letter only. No numbers, no equal signs, no negatives, no nothing. I can only cross out the exact same letter that I circled. I'm going to squish this last step in here, sorry. Step 4, I am then going to fill in with the underlined stuff. I don't have a better word there. Okay, I'm then going to fill that in with the underlined stuff. Really fancy, right? I don't know. I'm sure there's better wording. There are underlined terms, the underlined expression. Stuff will do. So we're going to go right here where we scribbled, where we crossed out. And we are going to fill it in with what we underlined, right? We underlined x minus 3, so I'm putting in its place x minus 3. once we do that, we now have something that we know what it says. Okay, so this now says x minus 3 equals negative 3x plus 25. Right, do you see how this gave me now a new equation? I'm just writing down what I see. Okay. I'm going to rewrite because I'm going to turn the page, but you don't have to. So x minus 3 equals 3x plus, this is a plus 25 or a minus?
Yeah.
Plus, okay. Now at this point, I would love to say, okay class, we all know how to solve this. I'm a little bit hesitant there, but we should all know how to solve this. We now have a basic equation with variables on both sides. Okay, which means our job is now just to solve this. Yes, Lori?
It's negative 3x.
Oh, this is a negative 3x?
Yeah.
Okay, thanks. Okay, so do we agree if we look at this and we go down our steps? Are there any parentheses? Nope, so nothing to distribute. Do we have like terms that we need to combine? Yes, right, we need to get these x's together. Are they on the same side of the equal sign, or are they on opposite sides of the equal sign? Opposite. So if they are on opposite sides, we need to get them together with the opposite sign. Okay, do we want to move an x or a negative 3x? Negative 3x, sure. We can move either, it doesn't matter. So what is x plus 3x? 4x. So now we have 4x minus 3 equals negative 3x plus 25. No 3x here. What is my deal today, guys?
What do you?
No, this is gone, right? This cancels. Good grief.
I wrote that in pen too.
Man, you white out? Do you want white out?
Yeah.
I don't think you should use that one. It leaked all over my desk. Ew, that's really gross.
Okay.
Shake it up well, because I don't use it very often. Okay, what are we going to do next to solve it?
Divide by negative 3.
Not divide. How do we undo subtracting 3? Add 3. Then divide by the 4. Okay, usually at this point my students are like, oh sweet, awesome, I now know what x equals. I'm done, I got an answer, circle it. Okay, but we're not done, because if we want to solve a system, we want to find a value for x and y. Question here.
Don't you have to put the 7 in?
Absolutely. So we're going to have to take this 7 and we're going to plug this back in. Okay, you can choose to plug it back into either equation. The easiest place to plug back in is where you underlined, because then it doesn't require any solving. Okay, so we're going to plug this back in where we underlined. Yes?
The answer.
Yep, what'd you get?
4.
Okay, so if we take this 7 and we plug it in right here where we underlined. Now instead of saying x minus 3, we're going to say 7 minus 3. Well, what is 7 minus 3? 4. Okay, so we just said, right, y equals x minus 3, but I'm putting this 7 in for the x. So y equals 7 minus 3. Y equals 4. You have two choices. You could write your final answer as x equals 7 and y equals 4. Or you could choose to write your final answer like an ordered pair, like we were doing on the graphs, and you could say x comma y, and that would be a fine answer as well. Okay, and usually at this point, my students are kind of like, holy cow, this is a lot of work. But keep in mind, I did all the notes with it. To actually make that substitution doesn't require all those notes we wrote down each time. Okay, the key is here that you have to be able to solve an equation. If you can solve an equation, then we're okay. So let's look at a second one here. How about x equals y minus 3 and 2x plus y equals 12. X equals y minus 3 and 2x plus y equals 12. Okay, we know that we're going to solve this by either substitution or graphing because those are the only two that we know.
We have to get y by itself.
Now, that's what I was just going to say. We could decide that we want to go the route of graphing and we could solve this one for y. That still leaves us with the 12 happening over here, which still starts to be a larger graph. Okay, but it is an option. But I'm telling you right now, I'm not going to let you. Right? We're pretending. We're pretending that we don't have to use substitution, so I don't have to choose numbers like 147. Okay? So we're going to look. Do we see somewhere up here that says x equals or y equals? Yes, right? Up here on the first one. So step 1 says we're going to circle it. Okay, step 2 says then underline what it equals. So what does x now equal?
Y.
Y minus 3. Step 3 says to cross out the letter that we circled in the other equation. So what letter did we circle? X. So we're going to the other equation. And the only thing that we can cross out is the letter that we circled. No numbers, no signs. I circled an X, I'm crossing out an X. You cannot scribble out or cross out anything other than the letter. Okay, and in its place, we're going to fill in the underlined stuff. We underlined y minus 3. What operation was happening in between this 2 and the x? Multiplication. How do we represent multiplication if we want to multiply 2 times y minus 3? If I do that, then it will just be 2 times y minus 3.
Then make it y.
How else can we represent multiplication? Other than a dot. Parentheses? And my students say, well, Mrs. McKinney, how am I supposed to know to use parentheses? Guys, if you're not sure, just put parentheses. You can't really be wrong if you put them. You can be wrong if you don't put them. Okay, so because this had a number sitting in front of it, this one needs to have parentheses with it. Does that make sense? Okay, so we're going to say 2 parentheses y minus 3. I'm just following along with what's written. Plus y equals 12. Again, realistically speaking, that is the only new stuff. Because at this point now we're just solving. Okay, and we should know how to solve this. Step 1 says, are there parentheses? Yup, if there are parentheses, what should we do? Distribute. So this will come at 2y minus 6. Are there like terms we need to combine? Yes. So we need to get these variables together, right? Are these variables on the same side of the equal sign or on opposite sides of the equal sign?
Same sign.
Same side. Okay, so same side of the equal sign, same sign to get them together. 2y plus a y is what? 3y.
Add 6 and 12.
Now we're just going to start solving, right? So we add 6. 3y equals 18. Divide by 3. If you're like, holy cow, Mrs. McKinney, what are you doing? Come into plus time so we can do more practice with solving equations. Are we finished with y equals 6? Nope. What do we need to do with that? Plug it back in, and where did we say would be the easiest place to plug it back in? Where we underlined. So let's go all the way back up here to where we underlined. I mean, I never said this would be a tiny amount of paper, right? It takes up space to do a problem, but it's stuff we know how to do overall. Okay, so now we'll say x equals 6 minus 3. 6 minus 3 is 3. So we know that x equals 3 and y equals 6. Right? If we wanted to, we could also choose to write that as an ordered pair. And that ordered pair would then be x comma y or 3 comma 6. Any questions on that?